Hi everyone, and welcome to my talk, From PaaS to Kubernetes, combining the power of Kubernetes with the most innovative features of PaaS. I'm William Dennis, a product manager on Google Kubernetes Engine. And I'm actually going to be live tweeting my own talk today using an app called Buffer, so you can follow along with this hashtag. In particular, I'll be putting links to the source code to the demo on that, so if you want to grab that link, that's an easy way to get it. You can also ask questions with that hashtag, and if there's time at the end, I might take a few live, and we can continue the conversation later as well. All right, so let's talk about PaaS to Kubernetes. So PaaS has entered the scene just under 10 years ago now, and they were very revolutionary at the time. If you're unfamiliar with the concept, PaaS stands for Platform as a Service, and it was this innovative way that developers could kind of throw their code over the fence and have a platform worry about executing and running that code and hosting it for them. Prior to that model, developers typically had a fairly complex setup where they'd have to configure a host, install all the dependencies and packages they needed, and then deploy their code. It was painful enough just configuring this thing, and then once you had done that, the code was kind of just a pain to deploy as well. So PaaS has really revolutionized that. They made it really easy to get started. And they introduced this model of git push to deploy. So you could just push your code over, and then the platform would handle everything for you. There was also no infrastructure to manage. So you didn't have to worry about machines, you didn't have to worry about scaling, all those things were taken care of. And there were typically a lot of great SaaS kind of add-ons like databases that would complement the experience. What makes Kubernetes popular today for some of those same use cases, and this is not a comprehensive list, I'm really just talking about that kind of use case. One of the most important ones is, of course, language flexibility. So whereas the PaaS was kind of tightly coupled with the language, up to the point where it may even be injecting code during deployment that's specific to that language, Kubernetes, by running containers, you can run anything that runs in a container, which is just about anything. There's also a lot less vendor lock-in. As I'm sure you're all aware, Kubernetes is open source, surprise, surprise, and you can run it just about anywhere. So you're not tied to a particular vendor or a particular way of doing things. There's also some very nice resource optimizations in Kubernetes because you can bin pack a whole bunch of different services onto a shared pool of resources. And not only does that save you money, but that's also opened the door for some new ways to actually build applications. So rather than having these monolithic applications, you can really have a lot of different microservices that all talk to each other. And that's kind of possible because you can optimize and host all those microservices on the same machine, even if they have various different dependencies. It's also very customizable, so you can build your own pipeline and kind of configure it and get it exactly how you want it. And as well as a whole bunch of really great SaaS add-ons, there are now some really solid open source add-ons as well, like Prometheus is a good example for logging. And of course, you can deploy more than just 12-factor applications. So you can deploy stateful applications and batch workloads and a whole bunch of other things. Kubernetes, as you're probably aware, is a workload level abstraction. But what I mean by that is that you describe you describe your deployment as a set of workloads. For example, I want 10 of container A and I want 10 of container B, and I want them, say, deployed together because latency is a problem, or I want them spread around the world because I want it to be super reliable, or I want both. I want to have clusters of paired services spread around the world. Or maybe I'm doing something completely different. Maybe I'm rendering a movie, and I want to render it one frame at a time, and I want to render it on the cheapest CPU possible. So I don't want to pay for the off-the-shelf VMs. I want to get the preemptibles. Those are just 2-3 examples of what Kubernetes can do. It can really represent a whole lot of different workloads, which is extremely powerful. And I personally like the fact that it's built on this declarative style architecture. So you just tell it what you want, and it's kind of Kubernetes' job to make that a reality. So you say, I want 10 replicas of pod A, and it's Kubernetes' job to make that happen. Certainly you can observe what's going on and check it, but you don't have to actually manually intervene too much. I like to think that Kubernetes sits at the ideal level of abstraction. So it doesn't go too low level, so you're not managing machines, just the same with a PaaS, but it's also not too high level, so it's not interfering with your code itself. It's just going to run your container. It's not modifying the code. It's not tightly coupled. It's not interacting with your code. So really, it's just sitting beautifully between the infrastructure and the application. Whereas by comparison with the PaaS model, there was kind of this intermingling of the application and the PaaS. And I thought Brendan Burns said it pretty well last week in an article. Too many concepts with PaaS were mixed into a single monolithic product, and it was kind of hard to separate out the bits that you wanted. As far as the learning curve is concerned, PaaS did have a very nice learning curve. You could get started really, really easily, and you could deploy widely, and everything would be great. That is, of course, until you needed to do something that the PaaS couldn't handle, at which point I call it the cliff of despair, where suddenly you're trying to do this thing, it's not supported, and you're kind of looking over the edge into the abyss, into this world without that beautiful PaaS that you've been using, because it can't do what you need it to do, and you suddenly have to learn all those things yourself. Kubernetes, on the other hand, I think it gets a bad rap, perhaps fairly, for being a little bit tough to get started. But at the same time, you can do so much with it that it's a very valuable skill to have. And so I think, like, particularly, I'm guessing everyone in the room here are professionals. If this is your career, if you want to be a DevOps engineer, then I think learning the tool that allows you to express the most range of deployments and handle the most number of situations is ultimately the most valuable. And if that takes an extra day to learn, it's probably going to pay off. Which brings me to this point. So I've been thinking about this problem kind of for the last year about what I liked about PaaS, but also why I really like Kubernetes. And to me, it boils down to this. Kind of be wary of the things that make the simple easier, but the complex harder. So when you're looking at tools and when you're looking at things to improve efficiency, if you pick ones that just tackle the very easy problems, and they're like, hey, here's an easy problem, but we're going to make it even easier. And it's sort of like you look at that, and it's like, hey, that's pretty good. Like, I want that to be easier. But then are you going to have that cliff of despair 6 months later when you need to do something? So I think what Kubernetes does is it actually makes the complex kind of possible. And that's the real true power of it. And I guess that's the genesis for this talk. So we think everyone should be using Kubernetes. We're at KubeCon, after all. But are there some lessons we can learn from PaaS, and are there some things that we can bring in? So with Kubernetes, you're kind of in control. You have all of the dials, you have all the knobs, you can do everything. Even if most of the time you just want to turn on autopilot. All right, so what are the things to strive for when you look at bringing the innovative features from PaaS over to the Kubernetes world? I've got a bit of a list here. The first one is git push to deploy. I think this is kind of the basic building block. It's really nice to be able to just push the code and have systems take care of that with like a continuous integration pipeline. Let me just highlight a quick demo on getting this working. I mainly just want to show just how easy this can be. There are a whole bunch of tools that can do this. Some here today at KubeCon are like Weaveworks have one, GitLab, CodeFresh. They're 3 that I've tried. I'm sure there are many others. But let me just do a quick demo with Google. So firstly, I'm just going to do the manual process where I'm going to build this is just a very simple Node.js app. And I'm going to build that locally. And I'm going to push that up. And let me get a couple of watches going here. So I'm going to watch my deployments, my pods, and my services. And here's a deployment manifest I prepared earlier. As I said, I'll be sharing a link to all this code, so if you want to look at what's in that YAML, you can. It's fairly kind of stock standard Kubernetes YAML, of course, with the obligatory kind of craft at the top. The container that I just built, a readiness probe, which is fairly important. So the readiness probe just means that there's a little health check that's just pinging the container to know when it's actually up and ready to serve traffic. All right, so it looks like that manual deployment should be ready. Let's give it a try. Cool. All right, so that's pretty standard. That's nothing new. Let's add this to Container Builder and set up a very simple CI pipeline as the first step of getting this git push to deploy. The first thing I'm going to do is just create a source repository so I can put the code up. All right, I'm just going to add that remote. And so just copy that. All right, while that's going up, let's switch over to container registry and create a build trigger. So whenever I push a change, it's going to trigger a CI build. So we'll just select that repo that I just created. And I'm just going to leave everything default here. So it's just going to pick up the Docker file and build an image. Again, pretty standard CI. To make it interesting, let's make a change in the code. So let's just say, hello, KubeCon Copenhagen. Push that up. Okay, so I'll go to the build history here, and I should be able to see that the build trigger has indeed triggered and is going to build that container for me. So it's pretty much doing exactly what I just did locally, but now it's doing it in the cloud. Okay, and we're pushing it up to the registry. And once that's ready, this is the image that it's going to create. So it's just I'm just using the SHA as the tag there. And I can deploy that image just using kubectl set image. We're going to see a rolling update happen. It's going to take about a minute. And while we're waiting for that, I'll skip ahead to the next bit. And that is, this is only going to give us continuous integration. Obviously, what we're striving for is git push to deploy. So we need the CD part. So let me just edit this trigger. And I see there's another option here, which is a cloud build YAML. So this is a little bit more advanced than a Docker file. It allows me to actually specify a bunch of steps. And one of those steps can be deployment. All right, let's see how this is going. Still got a couple of pods waiting to terminate. Might still be serving some traffic. All right, there we go. So that one's working. Now let's get back to this up-leveled build trigger that I just switched over to. So in this case, we're using this cloud build.yaml, which has just 3 simple steps in it. The first step is the build, using the exact same command I just did locally. The next is the push, again, exactly what I showed locally. And the final step is using the kubectl container, where we set the environment variables, which has the convenience of actually automatically provisioning all the credentials it needs. And then we're doing a set image, which is exactly what I ran on the left here. All right, so let's make a change and push that up and see if it all works. All right, so we'll switch over to the build history. And we can see that build is happening, going through those same 3 steps that I just configured. So this is really nothing groundbreaking. I just kind of wanted to show just how quick and easy it is to bring this pattern into Kubernetes, that it doesn't have to be difficult. So you can see we've built the image, we're now pushing the image, and hopefully the final step will be a deployment, which is here, kubectl set image with that image I just built. And we can see that it looks like the container's already been created. We're just waiting for them to become ready. And I'll take another 30 seconds or so. So like I said, I did add a readiness check to these containers, so it's just going to wait until it's actually able to receive traffic, which is certainly good practice to do. Still got 2 containers to go. Should only be a couple of seconds more. All right, let's give that a try. All right, so that is git push to deploy in, I think, about 5 minutes with Kubernetes. Let's get back to the presentation. So what other things should we consider as we bring the most innovative features into Kubernetes? Well, one thing is, that was a very simplistic demo I just gave. As I mentioned, Kubernetes is a declarative style infrastructure, so that does mean you have a lot of configuration, which is declaring the state of your deployments. So typically, you may want to take that very simple pipeline and make it a little bit more complex using this concept called configuration as code, where you just commit in all of the Kubernetes manifests into the source control, where it can go through the same code review processes that your actual application goes through. And you get some nice properties like rollback, being able to roll back a deployment, a Git rollback, being able to roll back a production deployment. And you might end up with two pipelines looking something like this. The one at the top is for the code repo, which is just going to build the container. The bottom one is another pipeline where all it does is look for changes to the configuration, which it rolls out. And then the dotted line in between is an optional step you can add, where you can just get after it's built the image, you can just update the configuration automatically. And you can tailor that to whatever staging, production type setups you want. Another really innovative feature that I think you probably will want to bring to Kubernetes is the concept of review apps. So assuming that you're doing a code review style workflow, which is certainly highly recommended, what review apps do is they can create an ephemeral instance of the entire application with the code that's under review. That means that your code reviewers can not only review the code, but they can actually try it and see it running live. Kubernetes really supports this concept well, because Kubernetes has namespaces where you can isolate various different workloads. So you can actually have just an ephemeral namespace just for that review app, running in the same cluster potentially if you want as production. And you can even share the same names. So everything can just have the same name because it's scoped to the namespace. So you don't even have to fiddle and rename everything and try and link it all up again. Portability is obviously important. So I mentioned it at the outset, one of the very great things about Kubernetes is avoiding this vendor lock-in. Well, you don't avoid lock-in if you end up with something that's not portable anyway. So to solve that problem, we actually created this program called the Certified Kubernetes Program that Dan Cohn introduced at the last KubeCon in the keynote. If you're using a certified Kubernetes vendor, you can have a fair degree of confidence that whatever you do is going to be portable. And the good news is it's very easy to actually find a certified Kubernetes vendor because it's basically all the vendors. So there you go. Let's just make sure that stays true. The next thing, of course, if you're coming from the PaaS world, I think, is that you want to automate everything. Wasn't it great not having to worry about infrastructure? Well, you don't want to come to Kubernetes and have to worry about infrastructure, I don't think. Certainly speaking for Google Kubernetes Engine, we offer automation for just about everything. So we have a cluster autoscaler, which can automatically add and remove nodes as your workloads change, scaling up to handle demand and scaling down to save you money. We have a bunch of features for the nodes as well, such as node auto upgrade, making sure that you're up to date with the latest version of Kubernetes, and auto repair in case something happens to the node and it needs to be replaced. So I think if you're using a very automated version of Kubernetes, then you get back to that not having to worry too much about infrastructure anymore. But you still get to keep all the benefits of Kubernetes, like the resource optimization. So as we do this transition, I think there's also a few things to consider carefully. One is poorly supported dependencies. So I mentioned at the beginning, one of the great things about Kubernetes is that there's this wonderful community of open source tools that you can use. Of course, you definitely want to make sure that those are actually well-supported open source tools. We had this motto at my startup back when I was working there kind of 6 years ago, that if you clone it, you own it. Now, the exception to this is when it's a very, very well-maintained and very reliable dependency, such as things like, obviously, Kubernetes itself, Linux, and projects with a lot of community backing. But if you're just cloning some repo that has a couple of dozen stars and no commits in the last 6 months, that's definitely something to consider. You'll effectively become the de facto maintainer. Build packs. So build packs was something with the PaaS, very popular, where it actually took your code and turned it into an artifact kind of like a container that could be deployed in the system. It does this by analyzing your code and kind of working out what dependencies it thinks you need and building up an artifact for you. I think in the Kubernetes world, this is a bit of an anti-pattern because you kind of lose a lot of the benefits of containers in the first place. I personally found, in my journey to Kubernetes, there were certainly some hard things that I had to learn. But one of the simplest things I found was just containerizing my app. You just go online, you find a good template, you copy it, you tweak it, and that's it. You also get a lot of benefit from that step too, because now that you've actually containerized your app, you can test it locally, should you wish, just straight from the Docker container. So that'd be something that I'd probably avoid, personally. The build pack model also meant that you would break on deploy. So you could actually have everything working nicely locally. You run like node locally, everything works. You throw it over the fence, and it breaks because the build pack doesn't work. Obviously, with Docker, you solve that, and you solve that earlier in the process, which is nice. Pricing models, I think another thing to just consider carefully with Kubernetes. So whether you go for like a node-based one or a container-based one. I personally like the benefit of Kubernetes that you can bin pack a whole bunch of services and workloads onto a shared pool of resources. That typically only works with the node-based pricing. Obviously, there are a lot of considerations here, but just something to consider. Right, so now I'd like to talk about rapid application development on Kubernetes. So far the talk is focused on how to bring some of those great features of PaaS into Kubernetes. Well, now that we're in Kubernetes, what are some really great things we can do? So the containerization part solved that break on deploy that build packs had, but you still probably do want to test the actual complete deployment of Kubernetes, including the manifest files. Also, if you've adopted the microservices style of Kubernetes for your application, the microservices architecture, you'll probably have a lot of dependencies that you may need to bring up as you're testing locally. So if only there was a good tool that could solve both these. Well, as you might have seen in Aparna's demo this morning in the keynote, Google recently open sourced a very neat tool called Scaffold, which enables rapid application deployment, rapid application iteration with Kubernetes. It's very simple to use too. So I'm going to do a little bit of a longer demo than what she did this morning for you. You just have to drop in this one configuration into your project. And there's really only three things that matter here. I'm specifying the image name that I want it to build. I'm directing it at the manifest files that I have in my project. And I'm just specifying what profile I want to use. So you can point this at Minikube using Docker locally, or you can point it at a cloud builder using a cloud Kubernetes service. I'm going to be demoing the latter today. All right, so we have this application already. And I'm just going to reuse this namespace since it's a demo, but obviously normally you would just create a separate one for development. Let's just tear that one down. All right, so do I have my scaffold file? There it is. Now if I just run scaffold dev, it's going to first build a container based on the code that's in that directory. And it's actually going to deploy that. So as you can see, I'd already deleted that deployment. Now it's coming back up, 3 seconds, 5 seconds old. And the important thing is now it's just sitting here waiting for changes. So this is actually watching my code and waiting for me to do something. So right now, if we went to that service, it's just going to show the exact same demo that I already had, because the code hasn't changed. All right, so let's say do something new. I'm going to prepare for maybe KubeCon Shanghai. Get ahead of the curve here. So as I hit save just then, you'll see that this thing, which was waiting for changes, just triggered a build, which is already finished. It's pushing. And as you can see, it's now just rolling that change out. So we have containers just created 6 seconds ago. And be aware that the only thing I did was hit save in my IDE just then. I didn't do anything else, I just hit save. Scaffold is watching that code repository and ready to make the changes. The other thing it's doing is it's actually watching for configuration changes. So if I actually edit the Kubernetes manifest and say change the number of deployments from 3 to 5, you'll see that change get rolled out as well. In fact, I can show that right now. So here we have the Kubernetes deployment with 3 replicas. I can just make that 5. And you can see that it's just redeployed that. And pretty soon we should have 5 containers. Let's check that demo app and see if the update is taken. Cool. So the nice thing about this is that you can go from developing to previewing your code live in production. This is actually in the cloud using GKE in less than a minute. And there are definitely some benefits of using even a remote server, I think even for development. Like with Scaffold, if we can reduce the deployment time down to 1 minute, then if you have like a fairly complex application with say like 10 different services, or if you just want it to run fairly performantly as if it was in production, kind of more close to your production environment, then it's just nice to just use the remote Kubernetes service. Of course, you can use Minikube as well. I personally find, at least on Mac, Minikube is a little bit slow because it's having to spin up a Linux VM to run everything. Okay, so what if I make an error in my code? This is Node, so any code errors here are just going to be runtime ones rather than build time. I'm just going to put a little typo in this method call, and we'll see what happens. So as before, Scaffold is watching for the changes, and it's rebuilt the image. No errors because it's Node. And one of the nice things about Scaffold is that it's automatically going to be connecting to those pods that are running and piping the output right in the console here. And so I can immediately see, oh, there's an error coming out of those containers. Clearly, header is not a function. So let me fix that. And it's going to redeploy it. And I really like that as well, because that solves kind of one of the annoying things with Kubernetes where you build, you sort of deploy it, you're watching the deployment, everything rolls out, it looks great. And then you're sort of like, now what? Why isn't it working? And then you have to start logging everything and trying to work out what's going wrong. So the nice thing about this is that because it's automatically attaching to the log output of those containers, you're going to get those logs straight away. And once those containers are all gone, we should stop seeing that error, and we'll be back up and running. Cool. So that is rapid application development with Kubernetes. And that completes my story about PaaS to Kubernetes, combining the most innovative features of PaaS right into Kubernetes. I think we have some time for some questions. So please ask away. Let me see if anyone's asked anything on Twitter as well. All right, no Twitter questions. Any live ones? Yes. Right.
How do you think Scaffold fits into this? Because that's, I feel with a lot of these, getting going with containers and Kubernetes makes it really easy to deploy your first app. But if you have things like authentication,
right,
TLS, XML, whatever, it becomes complicated. And how do you think?
Great question. So the question is, I mentioned earlier that beware of things that make the simple easier. Doesn't Scaffold make the simple easier? And what about pitfalls like making sure the TLS things are working and everything? So I think Scaffold solves one particular problem, which is the rapid iteration at the development stage. What it doesn't do is it doesn't replace a good CI/CD pipeline with review apps and staging environments and production environments. So to me, it's just one component of that. But I do think that if you're using Scaffold, it does get you closer to production. Because you're using Kubernetes, and because you can kind of wire up all the microservices you're using, what it means is that that's actually probably a lot more close to production than if I just ran Node locally. And there is one pattern that I observed in the past as well, which is where people would say just run Docker directly. I've built the container, why not just Docker run that container, or why not use Docker Compose and just describe my services again. I think Scaffold is a little bit better than that because you are using the same Kubernetes manifest that you deploy into production, you're probably getting closer. So I think anything that gets you closer to production is better. I guess I see it just as one complementary tool in the toolbox and not kind of replacing a good CI/CD pipeline. Thanks for the question. That's a really good one. Another one. Are you still using the container registry when you're using Scaffold? The good news about Scaffold is that it's very pluggable. So you can. The demo I showed was using a Google Container Builder. So the same tool that I showed in the earlier demo was being used by Scaffold. And that's configured here in the profile section. So it's using Google Cloud Build, and I've given it the project ID. You can actually just run it locally with Minikube as well. So you can attach a different container registry. You can just run the container locally in Minikube. It's a very, very pluggable system. It works with Helm. It works with just raw Kubernetes manifests. So it's really unopinionated about what tools you want to bring in. It'll work with other public clouds as well. So, yeah. Thanks for the question. Was there one at the back there? Nope. Yes. You might have to shout, sorry.
In your example, you press save and I'm guessing you watch for file changes and you upload something. If you have a more complex application, say a Golang application that takes a couple of minutes to build,
Right.
and maybe changing the types directly, you make some sort of change somewhere else, basically across a bunch of files. Will it start building every time? Is that
Very good question. So the question is, in my example here, I was making a very kind of simple and contained change. What would happen if you're making lots of separate changes? Well, let's give it a try. So I'm gonna make a change here. I won't save it. Well, actually, I'll save that, and then I'll very quickly. Well, maybe I'll just make another change. We'll see what happens. So I think what it should do is it should cancel the previous build and just start a new one. I guess I need a longer build. Well, let's try it again. What happens? So I think it is actually doing what I expected. It's interrupting that other build and it's just starting it again. So I guess you might be burning some cycles there, just building stuff you don't need. But the good news is, like, if you're saying it's going to take 2 minutes to build, that'll at least be 2 minutes since your last change. So I hope that answers the question. All right, I think we've got time for just 1 or 2 more, if anyone has another question. Yes?
How do we install this tool?
Scaffold, how do you install Scaffold? Right, it is fairly straightforward. So you can just see it on GitHub. And we made it pretty easy for you. So as long as you're happy trusting Google and just running shell commands straight from us, which I think you should be, but you can always look at it first. You can just execute this command and it'll install it into your bin directory. I was actually surprised how easy it was to use. Like, it was literally just, I ran that command, and then I created this file. I adapted it from the template. I changed the project name there, and pointed at my Kubernetes manifest. So this line here is basically just saying, my Kubernetes manifest follow the convention K80s -- that could also be in a directory. That was basically it. Pretty easy, actually.
Listen to hooks from Artifactory or something like that, because in big organizations, we push our artifacts to, for example, an Artifactory repository.
That one I'll have to get back to you on. So the question was, can it listen to hooks from Artifactory or other Artifactory repositories? I feel like maybe it should be able to, if it doesn't today. But I'll take that as a follow-up, and I'll have to get back to you. All right, one last question. Do we have any? Great. Thanks, everyone, for joining me today. Enjoy the rest of KubeCon.